Okay, I try to go through, and yeah, I want to present some new scenarios within this SSP session. Scenarios that we call structural change scenarios. And let me directly jump into the topic by giving you some background. So in case the slides don't switch, let me know. So you know that the SSP scenarios represent a consistent set of socioeconomic assumptions that can be used by the integrated assessment models. But it's not a complete set. So there are already some attempts to extend the SSP framework in different directions. And the attempt that we undergo is to use a driver that is missing so far. That's the evolution of the sectoral structure of the economies. Or in other words, the allocation of the economic activities among broad sectors of the economy. So one can relate this to a critique that IAMs are facing. So the critique that says that the assumed speed of decoupling between economic growth and energy use is sometimes unrealistic, in particular for developing countries. And this is supported by some empirical facts. So historically, we see a sharp increase of energy consumption in early stages of the economic development. So in the transition from agricultural-based to manufacturing-based economies. And scenarios that take these structural or transition process into account can help to generate more improved energy demand scenarios, and also can help addressing climate change impacts and mitigation on a sectoral level. In order to give you a bit more insight how we understand structural change or structural transformation, look here the graph on the lower part of this slide. So what is shown here are empirical data points for the labor shares. So we have the labor shares in the three sectors: agriculture, manufacturing, services, which depends on the GDP per capita or GDP per worker. We see that with increasing GDP per capita, the labor shares in the agricultural sector decline. In the service sector, the labor shares are increasing. And we have these hump-shaped, very pronounced hump-shaped curve in the manufacturing sector. And here we see a peak of this manufacturing labor shares at a level of around 25 to 30%. So we try to develop some structural change scenarios that reproduce these observed empirical patterns and are characterized in the following way. So the sectoral resolution should be or will be agriculture, manufacturing, services. The scenarios should be available for each SSP, each of the 5 SSPs. And the metric in which we measure structural change are by these 3 share variables: employment or labor shares, value-added shares, and energy shares. Using share variables has the advantage that if models want to adopt these scenarios, they can use these structural change scenarios independent of the data sources they otherwise use. Okay, so we start to construct these scenarios by building a regression model, running a cross-country fixed effect regression. You see here on the right, on the left-hand side of the of this regression equation, there we have the share variable. So the x in relative terms. On the right-hand side, we have the correlation coefficients beta. And as the main explanatory variables, we have y, the GDP per capita, and u, the urbanization rates. We feed our regression model with historic data from the WDI database. The WDI database has quite good coverage of countries, but rather short time series. We alternatively use the Groningen database, which has the opposite characteristics. So less countries, but more time periods. So now some regression results. So in the upper part, the regression coefficients beta. It's not very informative for the GDP per capita part, but if you look to the bottom row, to the last row of this table, where we see the correlation with the urbanization rate, we can make some interpretations out of these numbers. So we have a negative value for the labor share in the agricultural sector, which means that we expect that with increasing urbanization rates, we have a decreasing share of labor in the agricultural sector, and on the opposite, an increasing share in the service sector. Qualitatively, the same pattern we have also for the value-added shares. But for the energy shares, we see a different pattern. We have two negative values. That means that we have, with increasing urbanization rates, and decreasing energy share in the agricultural as well as in the service sector. But this directly implies that we have increasing shares in the manufacturing sector. We try to test the quality of our regression model by computing the mean average error, so the deviation between the model results and the observed data. And for all of these 9 share variables, we see quite good fit. So the mean average error is less than 3%. So we think it's a quite good result. And you can see this also on the next slide, where we show the model results as dashed lines and the empirical data as a solid line for 12 world regions, and again for the labor shares. So I hope the quality is good enough that you can see that it's a quite good fit. So now to the projections. In order to construct the scenarios for labor shares, value-added shares, and energy shares, we take the estimated correlation coefficients beta and combine them with GDP and urbanization rates projections that we get from the SSP scenarios. Then we use initial data for the sector shares, and we also have to observe the feasibility constraint, so that the sum of the sectoral shares has to be always 1. And from that, we can construct our scenarios. With respect to the GDP scenarios that we take out from the SSP database, I want to note that we have corrected these scenarios in order to match recent trends, and that also includes the COVID effect. So now, finally, some results. You see here for the employment or labor shares, again for the 3 sectors and for 4 selected countries. So in the above, in the first row, you see China, then India, Sub-Saharan Africa, and at the bottom, the US. So we see at the first that we can reproduce these empirical patterns. So we see decreasing shares in the agricultural sector. We see increasing shares in the service sector, and we see also these hump-shaped curvature in the manufacturing sector, while the peak is different in time for the different regions or countries. So we see this peak in China today. We see, or we expect to see it in India in 20 or 30 years, and further ahead in sub-Saharan Africa. And for the US, we probably have seen this in the past. With respect to the SSPs, we see much larger variation in the developing countries. And what we also see is that we see the fastest changes always for SSP5. So that's the purple line. And the slowest changes always under SSP3, the green line. And with respect to SSP3, we also see that if you look to the graphs for sub-Saharan Africa, there's hardly any change in the sector shares. That's a kind of story that stops this whole transformation process. Okay, so we see qualitatively similar results for the value-added shares. For the energy shares, they are a bit different. But because of the time, I don't want to go into the details and come to the conclusions. So we produced structural change scenarios that can reproduce historical patterns. We see that the economic transition is fastest under SSP5 and slowest under SSP3. And with respect to the latter, we also can make the conclusion that the absence of the takeoff in the manufacturing endangers under these SSP3 scenario, the needed infrastructure and low carbon investments in sub-Saharan Africa. So we have constructed these structural change scenarios. They are now available for each SSP, and we are happy to share them with the community. These scenarios are available at the level of the 12 Remind world regions, as well as on the country level, currently until 2050. And as part of the future work, we try to check the robustness of our scenarios, which are based on a quite simple approach, by using a multi-sectoral growth model that runs in order to make the projections, and then we can compare how robust our results are. Thank you.
Thank you very much, Marian. I think it was really interesting. And maybe the data, are you going to share it via a downloadable link, or? Yeah,
I think that the idea was, to put it in a Navigator database. Okay. So I think we should have this in a central database. So nice. It's, yeah.
So maybe once you have that, it would be great, I think, for the community to get that information on where to get it. Maybe you could also via the IAMC newsletter or something like that, spread that around.
Okay.
In view of time, I'm moving directly to the second speaker. Note that there is the Q&A tab. And so if you have questions, please type them into the Q&A. Also to Marian, just type in the name of the speaker, and then the speakers can go to the Q&A tab and answer questions as well. Okay, the second speaker is Jing-Yu Liu from Shanghai Jiaotong University, and she will be speaking about a research framework for phosphorus demand projections in China using the shared socioeconomic pathways. So please share your screen as well.
Thank you for the introduction. So I'll go to the content today. Phosphorus is a key element for life system. Over 80% of phosphorus use is for agricultural activities. So fast-growing world population causes pressure on the phosphorus resource security, and which is related to food security. And phosphorus fertilizer use can cause water pollution like eutrophication and other problems. And another key issue here is the biomass related to our climate net zero emission goals. So the production of biomass will require a large amount of land, water, and soil fertilizer. So based on this background, I will aim at projecting future phosphorus use in China through 2100 year. To do that, I employ a research framework using SSP scenarios, and I also assess the potential of resource recycling and efficiency improvement and in reducing phosphorus demand on different socioeconomic scenarios. And this is the figure for the framework. So we collect historical data from a published paper in 2016 on PNAS. The phosphorus material flow analysis contains information about soil phosphorus, sediment, crop uptake, waste management, and efficiency information. And then we collect scenario assumptions and data from MCG, like food production, land area, GDP, population, and so on, using SSP scenarios. So we input this data and scenario assumptions into our forecast model system. The core of the forecast system is a soil model called DPPS model, which is also published on in 2012. And other methods like regression assumptions and phosphorus flows are included in the forecast system. So our objective is first to project future phosphorus demand, and then to assess the P efficiency improvement. And we also would like to assess the synergies and trade-off of cross-policy domains. And next is the scheme work of the material flow for China. The data is from mining of phosphorus to production of a fertilizer to the food production and consumption and end of use related to phosphorus flows, and also includes natural process like weathering and atmospheric position and runoff. This is the scheme of DPPS model. It assumes that input of fertilizer with phosphorus would go into two different pools. One is stable, and the other is providing available phosphorus for grown crops. So this is the assumption that this is the projection methods that we use. The phosphorus uptake in crops would be calculated using agriculture production from MCG and P content data from of products from literature. And the DPPS model is the core. It uses historical data for calibration and use P uptake as exogenous variable. And we treat wind, erosion, weathering, atmospheric deposition, and detergents consumption, and P loss, and sewage and wastewater, solid waste, manure, and fertilizer efficiency assumptions, and using projection methods to do. This is the different assumptions for SSPs, and it includes GDP, population, urbanization used for regression, and globalization for trade, and meat preference, yield for assumptions in productivities, and fertilizer efficiency, and sewage and wastewater treatment, manure management, and P loss in supply chain. Different assumptions in SSP scenarios. And then the results would be this. In this figure, we show the phosphorus uptakes and phosphorus fertilizers in different clusters of lines. Dotted lines are fertilizers. So the results show that SSP3 and SSP2 would have the largest phosphorus uptake because the population and dietary style. SSP1, the dotted line, is the least phosphorus fertilizer use scenario. And this figure is showing different measures, different phosphorus measures, the potential of measures to reduce the phosphorus demand. And the largest potential lies in the fertilizer efficiency improvement. And the second largest is the manure management. And so in 2100 year, these two measures could reduce more than half of the demand. In addition, we want to analyze the synergies and trade-offs for different domains policy analysis. This is an example showing how we compare SSP2 BAU and SSP2 BAU plus yield improvement scenario. These two scenarios, we would have 5 dimensions of impacts: phosphorus, energy emission, cropland, water, and agriculture intensification could reduce 5% of phosphorus demand in China. And so this research can add one more dimension to the nexus assessment for related policies towards SDGs and within the SSP scenario framework. Other policies can also be assessed, like dietary change and food waste reduction, but I have not done yet. And future steps includes a biomass treatment, which I have not done yet either. So we focus on the P treatment in biomass technologies and the consistency between IAM models and P flows associated with bioenergy. And the second is the case study of China can be expanded to global scale. And the third is this research framework can serve as an example of incorporating resource efficiency modeling for some resources in IAM models, expanding SSP scenario framework with more socioeconomic dimensions. That would be all. I'd be happy to take comments and questions.
So as indicated before, please type questions into the Q&A box, preferably even during the presentation. In calculating demand, is it important also to follow the amount of phosphorus that is already in the soils? Because maybe depending on soil saturation, also demand for phosphorus will change.
Yes, the historical data would be simulating the dynamics in the soil. The original data coming from another published paper can trace back to 1600 years, but I only use recent years data, like from 1970s data. And so this accumulation of P resources in the soil can be simulated using the DPPS model.
Wow, nice. I'm just seeing whether further questions appear. If not, I encourage people still to bring in questions during the Q&A, during the next presentation, but I would like to move then to the next presentation. So could Jeff BIELICKI come on stage? So the next presentation is about scenarios for the US Great Lake regions using the SSPs. And please go ahead.
Great. Are you able to hear me?
Here we are.
Okay,
and
great.
We also see your slides perfectly.
Okay, great. Well, it's a pleasure to I would normally say be here, but to see so many people from around the world participating in this. I'm going to talk about are scenarios that we've developed for the U.S. Great Lakes region of, it's in the upper Midwest of, or the east north central portion of the United States. And I'm gonna step back a little bit and discuss the motivation for this work. So basically, as you know, globalization has progressed over the past number of decades and yielded a lot of aggregate benefits due to the relatively free flow of capital, people, goods, services, and so on. For example, here's the GDP over the last 100 years for the United States. But with this globalization has come some backlash and concerns that have ended up being quite consequential. Issues like erosion of manufacturing jobs, increasing income inequality, environmental conditionings getting worse elsewhere, a recoil against trade and places like the WTO that promote trade, increasing nationalism that's affecting immigration and refugees, as well as I'm sure you're aware, more recent implementation of tariffs and counter tariffs and so on. So a bunch of us got together and said, well, if we have this retreat from global integration, how might that deglobalization affect food, energy, and water systems in the Great Lakes region? The Great Lakes region encompasses these 5 states here: Michigan, Wisconsin, Illinois, Indiana, Ohio. They are important in the United States for a variety of reasons. They, as a substantial amount of agriculture, corn and soy being located in the eastern corn belt, has a long history of conventional and unconventional, more recently unconventional, fossil fuel development and production. The Great Lakes themselves, those 5 lakes there, account for about 20% of the world's freshwater resources. It has about 15% of the U.S. population and about 13% of the U.S. GDP in these 5 states. Now, with all these activities come a lot of concerning impacts. For example, toxic, harmful algal blooms developing in this case, this is Lake Erie, due to nutrient runoff and warmer surface waters. So since we were interested in this deglobalization and food, energy, and water intersection, we sought to establish scenarios on axes of higher, lower sustainability versus higher and lower trade, trade being a proxy for global openness. So we've established 5 scenarios, a business as usual that we're pegging right in the middle of this intersection, as well as 5 or 4 others in these quadrants. And we're interested in these regional concerns for energy, land use, water quality, environment, and so on, as well as the correlation with trade and policy or climate policy. Now, of course, our region on the right there is nested within a nation, which itself is nested within a global context. And our scenarios have to be appropriately constructed to take into consideration this multi-scalar issue. So what we've done is taking data from the SSPs as well as from OECD and US and national level data, for example, crop production and energy from each of these sources. We have integrated energy projections. I'll talk a little bit more about that later for the region. We're also using watershed and field, farm field scale data on water quality, the crop choice, and so on. And we've got, also got state, county, and 30-meter remote sensed data, for example, on land use that we've integrated to help produce these scenarios. So the scenario production or construction has proceeded through a number of repeated interaction with multiple stakeholders. Obviously our team, which has grown to be about 25 people, including students. We have a research advisory council that meets once a year. Subsections of that are on our participatory modeling assessment teams to ground truth what we're doing. We also have had a number of focus groups with farmers, in part because what we're interested in is how they might change their behavior as a result of changes in or change their cropping decisions as a result of changes in international demand. Now, we're in an SSP session, so I don't need to talk that much about the SSPs, other than to say, you know, these are established on on axes of challenges for mitigation versus challenges for adaptation. Now, what we care about is in this work is sustainability versus trade, and if you think about it, there's kind of a sustainability axis going along this diagonal here, where when there's low challenges for adaptation and for mitigation, it's conceivably higher sustainability, and the opposite when those challenges are high. So part of what we've done is, if we look at to help sort of use the SSPs to guide our scenario development, if you look at the narratives for each of the SSPs here, I'm just showing it, for example, SSP 5, you can kind of parse these narratives into issues that are consistent with higher or lower sustainability or higher or lower trade, color-coded as such here. This was one exercise, color-coded according to our axes. And what we did then is we had a meeting with our Research Advisory Council and said, okay, we gave them a piece of paper with the narratives, said cut them up and paste them onto our quadrants. So here they are, the result of multiple groups doing this, color-coded by SSP. And you can kind of see that they start to congeal in some way into the SSPs on their axes start to congeal to our quadrants. And in essence, when we dive into the details, they sort of mapped pretty well in this way. So that, for example, SSP 1 is higher sustainability and higher trade, is consistent with what we're envisioning as higher sustainability and higher trade. And SSP 3 is consistent with lower trade and lower sustainability, for example. So with this mapping, and then using some of the projections from the SSPs along with production data at the OECD level and the US level, we can project out, in this case, I'm just showing the business as usual, which in our case, we're using SSP2 as the proxy for it. The business as usual agricultural yield and how that, for corn, soy, and wheat, how that may, for the United States, how that may evolve over time, as well as we're able to put some, I'm showing a standard deviation on there. So we're allowed to put some variability around it. And with that, we can then parameterize our other modeling efforts with this year-over-year change in the productivities. So whether it reflects technological change or whatever, we have a long history of being able to get a little bit more out of the land over time, and this is how we've parameterized that in our modeling. We also, to see how other variables that we care about may proceed, had our Research Advisory Council participate in the factor actor sector stakeholder assessment. This is based on Absar and Preston, and the way we did this has a few controls. And at first we asked them, how is globalization going to proceed? And that's defined by a scenario, so they should have gotten that right, and they did. But also to have some sense of how some of the inputs to our modeling efforts may change, that are also being covered in our actual quantitative scenario development. What some of the outputs from our integrated assessment modeling may look like, GDP, land use, for example, and this is kind of a hypothesis test. And then we also have a sustainability assessment that we are conducting as a part of this work that has things like CO2 emissions and jobs and so on. So using this factor actor sector stakeholder assessment method, we implemented it in a way that allows us to derive useful inputs, but also have a check on our outputs. We have elicited mental maps This is what I'm showing of the stakeholder. This is what I'm showing for trade, energy, technological change, and land use, and how those are all coupled in the minds of our stakeholders. And so what I'll show a few examples of some of the projections. These projections for the our scenarios are color-coded by those quadrants. Here I'm showing forest area in our region, which has been increasing over time, and we project that it would increase more. Again, this is using a combination of global, OECD, US, and state level data. Here, I'm going to show some of the shared assumptions for energy derived from a blind elicitation of our project team. There was a correlation with economic growth and trade. So the what revealed itself was this assumption that lower trade leads to lower economic growth and higher leads to higher economic growth. For the sustainability axis, some issues with oil and gas fall into each specific quadrants for the supply and correlated the price. And then some of them cut across the axes for sustainability, low renewable energy costs for higher sustainability, carbon-free generation standards, and carbon dioxide price, and the opposite for the lower sustainability. So this allows us to then project price trends. There's a 5% interest or discount rate embedded in here. And this is all based on modeling that from the US Department of Energy and how we mashed it together with the team elicitation. So overall, we've got the scenarios in the upper left. We've got a number of different models that are plugging through, that are cranking through all of this, from the global to the national to the regional. This is how they're all connected. Don't expect you to necessarily follow all that, but this is how the scenarios are informing the modeling efforts. Basically, almost everything is informed by the scenarios. So again, we've got this iterative stakeholder engagement process where we've done this mapping of the SSPs onto our scenario quadrants, done some mental mapping, some regional expectations and hypotheses, collected, processed a whole bunch of data across a bunch of scales to do this multi-model integrated assessment. I'm Jeff BIELICKI, that's me on the left. The PI of the project is Alina Irwin on the right, and I'll leave it here to answer any questions. Thank you for your time.
Thanks, that was very clear, very nice. I was wondering, and I liked your exercise where you were more or less trying to couple the SSPs and your local scenarios. And when we were developing the SSP framework for the SSP1, more or less we had two possible choices. It's a high sustainability scenario, low challenges for mitigation, low challenges for adaptation. And we could think of a world that is technology focused, has a lot of trade. That's a possible storyline. We could have also developed a storyline that is much more local focused, maybe less technology focused, more lifestyle. At the moment, the current SSP1 describes the first world, but it's also in the paper already indicating that there's this other option. Because now, what you ended up having to do is that you put the SSP4 at the place where you had this high sustainability, low trade option. And I think already in your exercise where you were mapping it, it didn't really nicely exactly got into that spot. And maybe also if people think from the global storyline where it emphasizes, for instance, poverty and high challenges to adaptation, people might not really associate the SSP4 with high sustainability. So what's your response here, and how do you think about that?
Yeah, so that mapping wasn't perfect, as you might expect. We kind of had to make some decisions, and one of the things that we fell upon was that we're doing this for the Great Lakes region of the United States, and in a high income country. And so some of the parsing of the SSPs is high income countries go this direction and low income countries go maybe in a different direction. So that was part of what helped us make that decision. I definitely agree that this isn't a perfect mapping. But when we started digging into the details and the characteristics of things, it seemed like, and I can't remember if maybe that quadrant was the least clear fit. I just don't remember right now. But again, it wasn't perfect, but we felt relatively comfortable saying, okay, some of the characteristics of it are consistent with what we're interested in.
Yeah, I think your mapping works really well for the SSP5, for the SSP1, and for the SSP3. But for the SSP4, it seems to be a bit challenging, both on the sustainable direction, maybe even also on the trade direction, because K1 is, for instance, now in the Q&A also asking.
Yeah. No, I agree, and our that is how we map the SSPs. But in terms of developing the scenarios, the SSPs are one input among many, including the energy, the direction that energy may go with carbon prices versus not, and oil and gas supply and prices versus not. And so we did sort of, it's not a full and not close to full reliance on the SSPs.
Yeah, no. I think there were really nicely well elaborated scenarios at the local level. Given the time, I would like to end this session.